Hi, Year 9. Time to continue the journey of indices. So today we're going to be looking at two new laws, and we're going to just call them laws 5 and 6, and you can see them on the screen there. Remember last class we were talking about brackets, and I did questions like this. I had questions that went something like this. I might have had 2a to the power of 0, where there were brackets, which meant everything in the brackets was affected by the 0. Well, when you have brackets with a power, so here's brackets with a power, everything inside the bracket is affected by that power. So we do each part inside the bracket individually, and we can get the answer. And it doesn't matter if it's written as a fraction or if it's written as two things being multiplied together. Every part individually in the bracket is affected by the power. So let's try our examples. First one, we'll see that we've got negative 2a cubed inside a bracket, and it's all raised to the power of 2, so everything inside the bracket is raised to the power of 2. So the first thing we need to look at is minus 2 is raised to the power of 2, and then a cubed is raised to the power of 2. Now, another way of thinking of it is this is minus 2a cubed multiplied by minus 2a cubed, because that's what squared mean. It means multiply the bit inside the bracket by itself twice. Now, I wouldn't normally write this. I'm just showing you that it can be written like this. But if you write it like this, you can see that negative 2 times negative 2 is 4. A cubed times a cubed, add the powers when you're timesing, gives a to the power of 6. That's one way you could think about it, but the fastest way is to look at it and go negative 2 has to be squared. Negative 2 times negative 2 is 4. A cubed has to be squared. When you have a power to a power, you times them. 3 times 2 is 6, so that's why we get a to the power of 6. So this part here, you can ignore. You don't have to write it if you don't want to. So with this example, part B, we're going to have everything inside the bracket raised to the power of 5. Now I really don't want to write 2m cubed n to the power of 5 times 2m cubed times n to the power of 5 over and over and over 5 times. So what I'd prefer to do is look at each part inside the bracket individually and raise it to the power of 5. First thing we're going to do is 2 to the power of 5. Now 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, which is 32, and you can just do 2 to the power of 5 on your calculator anyhow. M cubed to the power of 5. Well, when you raise a power to a power, you multiply the two powers, and 3 times 5 is 15, so we get m to the power of 15. N to the power of 5 to the power of 5. 5 times 5 is 25, and there's our solution. Let's try part C. Now, part C has two brackets, so we're going to do this in two different steps, and then we'll merge them afterwards. So the first bracket, the 6 has to be squared. 6 squared is 36. And the d to the power of 7 has to be squared. 7 2s are 14. That's why we get d to the power of 14. Now we're going to multiply that by, what's 2 to the power of 3? 2 times 2 times 2 is 8. And when you're looking at the power of d, it's d to the power of 11 to the power of 3. A power to a power, you need to multiply them. 11 times 3 is 33. So now we're going to look at the 36 and the 8. We'll times them to get 288. And d to the power of 14 times d to the power of 33, you plus the two powers, and that will give you d to the power of 47. So there's our solution for part C. Now part D, we're dealing with a fraction, but everything inside the bracket is raised to the power of 4. So we're going to do each part inside the bracket individually, remembering there's a fraction. So we'll have the top of the fraction and the bottom of the fraction dealt with separately. The first thing, negative 2. Negative 2 to the power of 4 is negative 2 times negative 2 times negative 2 times negative 2, which will give you plus 16. If you put it into your calculator, you must remember to put negative 2 inside brackets and then raise it to the power of 4. A to the power of 5 to the power of 4. When you're doing a power to a power, remember we multiply them. 5 times 4 is 20, so we get a to the power of 20. On the bottom of the fraction I have an e cubed. That is to the power of 4. A power to a power, 3 times 4 is 12, and that's our final solution. Part E. We've got two separate brackets, so we're going to do it in two parts, and then we'll worry about what happens after we've done each bracket individually. Everything in the first bracket is to the power of 4, so let's deal with the m. M cubed to the power of 4. 3 times 4 is 12. Let's deal with the n. N to the power of 4 to the power of 4. 4 fours are 16. And on the bottom, q. Now, what you need to remember is that there is actually a 1 there. So 1 times 4 is 4, so it's over q to the power of 4. Times m to the power of 5. Remember, above that m, there's a little 1. There's little 1s above all of these. You don't have to write them down, but they're there. Q has to be raised to the power of 5. N on the bottom of the fraction has to be raised to the power of 5. Now we'll start tidying things up. To tidy things up, we're going to focus on the m first. Now there's an m to the power of 12 times an m to the power of 5. When you're multiplying, you plus the two powers. 12 plus 5 is 17. Let's look at the letter n. N to the power of 16 is on the top of a fraction. N to the power of 5 is on the bottom of the fraction, which means they're being divided. Even though there's a times sign, they're being divided because one part is on the top and the other part is on the bottom of the fraction. And when we're dividing, we subtract the powers. 16 take 5 is 11. So n to the power of 11. Looking at the q's, q to the power of 5 on top, q to the power of 4 on the bottom. We're dividing because one's on the top, one's on the bottom. 5 minus 4 is 1. So you get q to the power of 1, which is just q. There's our solution for part E. Time for you to try some questions. Enjoy the experience.